Everybody, hope you guys are doing well. So continuing on our journey, now we will be seeing some important thing, right? There is a very famous keyword that we often use while dealing with OP, right? Something called as self, right? Now in some languages, this self might be the self can be referred to as or this, right? So in some languages it is self, in some it is this, right? The meaning or the usage of how it is used is same. The self, it is used to refer the current instance of the object, right? So self for this, basically it is used to refer to the current instance of the object. Now let us see how does that work, right? Okay, so now this is a class, this is written in Python. We'll see these, so these are special methods, right? Anything which has underscore in front of them, and then some name, and then these are called as render methods, right? So these have reserved meaning in Python. They have a specific usage here. These are reserved and have and have a specific usage. Okay, now so we are creating two objects, right? So this is cp1, and even that has two attributes, name and age. So suppose this is my reference p1, and then this is my reference again p2, right? So if I would only be using name, right, then I don't know which reference is what, like which the thing is, this blueprint is written only once, right? So there might this blueprint will be only written once, right? So how will, and if I have two things here, how will the compiler or how will the PVM or any machine decide which object am I referring to? If I don't use this as self, right, what could happen is this could possibly overwrite, but we don't want any sort of override to happen, right? We want two distinct objects with their corresponding values, right? So for this we use something called as self, right? So this here is referring to the current instance. For example, when we do this, right, and we are having p1, so we are referring to the p1 instance, and when we are having p2, we are referring to the p2 instance, right? So this is how self is going to work, right? Now this is one of the very important properties. This will be used a lot, right? And so then you have something called as a constructor as well. A constructor is basically to if it's at a class level method or attribute, right, and if you want to assign it, so yeah, you use something called as a constructor. It is very similar to it's very similar to usage, nothing uh, uh, like nothing difficult, right? Now let's talk about some core pillars, right? So we were saying that we were going to talk about there are four core pillars, right, of OOP. If any language follows that core four pillars, then we say that the language what do you say, the language satisfies the OOP paradigm. So it may so happen like there may not it might not be like, for example, abstract, it might if it follows all of them, then it is a full OOP. If it does not follow any one of them, then we don't say that it is not an OOP. We only say that it does not follow one of the pillars of OOP, right? Now, first the first pillar is encapsulate, right? To encapsulate is basically to now what encapsule. So capsule, if you see a capsule, right? So capsule is coated from the outside. If you have ever seen a capsule, it's coated, right? And inside we have two things inside this. So once you have uh, so this inside we have two things, right? So we have inside we have the material, right? So basically the job of this capsule is to prevent the inside what do you say inside functionality getting exposed out. And the moment when you swallow, right, this capsule automatically breaks out. So same something on similar lines. So in what we do is we try to encapsulate attributes and methods, right, thereby preventing the user from outside knowing what is inside, right? So basically, in other words, this is nothing but bundling data. We're bundling data into two teams, attributes and methods, right? Now, how do you work with encapsulation? So the way that we do is we use something called as access modifiers, right? Now these access modifiers, what they do is uh, basically they are going to prevent the access, right? So you have public, private, and protected, right? So you have public, you have different access modifiers as well. The major ones of them are public, you have public, private, and protected, right? Now private is basically again can be accessed from inside, preventing the or restricting from outside. Public is can be accessed from anywhere, right? Open to all. Now protected is a combination behavior of private and protected. So the way the main goal of encapsulation is basically to prevent the attributes from being exposed outside, right? So that the way we do is we kind of add them an access modifier called as private. Now inside the class you access them using getters and setters, right? So for example, if you want to set a value from outside, instead of directly exposing that, you kind of use getters and setters. So these are special methods. These are going to set our uh, what to say private attributes. Now the reason for doing this, what first of all what we are making sure that there is an integrity, right? So our setter, you can apply some conditions to the setter. For example, if it's not an integer, if it's not a float, or if it's not of a specific type, it shouldn't be initialized, right? Now controlling access, because if this is something is private, right, if anything is private, access from outside is restricted, right? So if it's private, you can only access within or inside, right? So hence what we have done is we have added some level of abstraction or restriction, right? Now the drawbacks is basically the pitfalls is over encapsulation and under encapsulation, right? Over encapsulation is basically no, there are certain attributes that we can expose to the outside, but not that wouldn't hamper our internal code, right? So then even if we make that variable also as, for example, say even that we make it as our private, then we are over encapsulating, right? Under encapsulation is this is something called as tight coupling, right? So we'll see what this tight coupling is. Now this is something which is to be dealt later on. So again, and over encapsulation is basically unnecessarily making a variable private that is not needed. Now then the other thing that comes is basically abstraction, right? So abstraction is, now what is the difference between abstraction and encapsulation? Abstraction is basically hiding so in both we are so encapsulation is more about preventing access. It's not about it's about, so when we want to control access, right, then we go towards encapsulation. Now for example, now when we should go for abstraction, right, for example, if you have a remote, right, the internal circuitry is not visible to you, right, you only see the buttons, or the only thing that you have access to is the functionality, right, the buttons. I mean, so you'll be having the only access that you have is the buttons on the remote. Using the buttons you can perform the necessary functions, right. Now how that is getting performed is not our concern. So that is what is abstraction, right. So abstraction, what does is internal, so we kind of expose our methods, the internal logic of how that method is written, that is abstracted, right. So the key difference to understand is encapsulation is more about controlling the access. This is like access control, who can access it. And whenever we deal about abstraction, right, so abstraction is basically hiding the underlying implementation. So this is basically underlying implementation is what we are trying to hide. So we have two core things, right. Remember, encapsulation is something that is controlling the access. So you encapsulate it, like make it private, reduce the accessibility, like control the access, like who can access it. Now whenever you deal with abstraction is not encapsulation, it is basically hiding the underlying implementation, right. Now achieving abstraction, now there are two ways to achieve abstraction. One is basically using an interface, and the other is basically using an abstract class, right. Now interface, okay, now what is the difference between an abstract class and an interface, right. Now an abstract class will contain only an abstract class. If the class is made abstract, then it is not mandatory that it should contain only abstract methods. It can contain both abstract and non-abstract as well. Now the class that is going to inherit from it, or is going to what do you say, the class that is going to implement. So the thing that we use in abstraction is implement, right. There is something called as implement, right. The class implementing that abstract class will have to implement the abstract class as well as the so whenever we say the implement, right, so when we talk about implement, the class which is going to implement this abstract class and is going to the class implementing this is abstract class is going to will have to define the core logic, right. So whichever class implements has to define the core logic, define the logic. So if you're using an abstract class may contain an abstract as well as non-abstract method. So this is something called as partial abstraction. If you're using an interface, so this concept is applied in even in value types, right. Now struct also are so in certain languages like Swift, right, you have something, even in TypeScript you have something called as interface. So it's like a contract. So anything that is going to implement that contract needs to follow the rules of the contract, something like that. So interface will have method definition, right. This is fully abstraction of which we have achieved, right. Now there are, okay, let's not now when to use abstraction, again when we don't want the complex logic to be exposed, core flexibility, right. Again This is something important, right? You can implement abstract classes, you can keep on implementing it, and then you can add in more additional features. You can make the code more extensible. It is going to simplify our complex define, right? Because we are only exposing the method structure. How that implementation is happening, that is not of our concern right now. So that is something cool, right? So the two major pillars that we studied. Now in Python, unfortunately, there is nothing called Python does not have that feature of hiding, right? Uh, like that language is never was never meant to have any abstraction, so you cannot have abstraction in Python, and even encapsulation you can't do it. You can't have encapsulation, and like you can there is nothing like private keyword in Python, I guess. In other languages we have, in Java there is definitely so in Python nothing is so it is not a fully OOP language. It is not truly Python because uh, uh, there is nothing such as private. I mean, it may appear that it is private, but it's not. So, yeah, the thing is, like, unlike Java or other languages, there is no keyword like private in Python. The reason being, Python was defined or made to be a more simple language, easy to write, right? Private protected will still kind of make it a little bit difficult to learn the language. However, the aim goal of Python was, or the reason why it was developed was to have this, what do you say, uh, easy to implement, right? It's very easy to write code in Python, right? It's not that challenging. Okay. Now, so basically we have seen two pillars. One is the encapsulation thing, the abstraction. Now inheritance. Now this is a very important pillar in our way. Now just like how we say Python, right? Now there is something called as uh, a web language as well, right? Now why it's called as language of the web? The reason behind is or the answer to that is, so the browser can only understand three things, right? Even if you write it in another language, it can only understand HTML. The next thing it understands is CSS. The next thing it understands is JavaScript, right? So these are the only three things it can understand. So hence it is called as the language of the web. Now strangely, JavaScript is also an object oriented language, although even JS is OOP, right? So it is also an object oriented, although initially before ES6 it didn't have the class object thing, but it had some other type of behavior, right? So if any language follows those behavior, for example encapsulation, then we can say it, right? Now even JavaScript does this. Let's see how JavaScript uh, enables that. Now OP is defined by four own principles, as I said. Now first is, so then you have JavaScript. In JS you have something called as objects, right? So these objects can hold properties and methods, so then you are able to achieve access control, adding implementation or abstraction. Now this is now this is achieved by closure, right? Now what is the closure? Now since functions there are objects, right? Since in JS. Functions are not stored on this stack. They are brought to this stack, but they are the memory is created in the RAM, right? So then what happens is, so the memory is created in sorry, the space is stored in the heap, right? So the it is not garbage collected in the heap until the reference or the entire function is done execution, right? For example, if you have a function, right, and then inside this also you have a function, right? So now if you have any variable designed here, until and unless this function has been completely executed, it doesn't make sense. This scope is not lost, so it's still kept, right? This is nothing but called as closure, right? Now one biggest advantage, yeah, so basically what we are doing is we are hiding the inside implementation, right? The only I think accessible to us is the outside, the function that we call, right? The inner implementation, if it's mentioned in this closure, cannot be accessed directly. So this is how JS implements OOP, right? So first we said encapsulation. Encapsulation was using objects, right? Objects can have methods and attributes. The next thing that we came about was how we are abstracting, right? So abstraction is done by using closures. The function inside, we don't have direct access to it. Only the function that is the outside, the outer function, we can access that. So again, the inner function can hide the implementation, right? The next important pillar that comes is inheritance, right? So we haven't seen inheritance as an OOP feature. So you see OOP, right? Now inheritance, right? Why was it introduced? Is the let's understand, right? So again, the whole purpose of this was to bring was code reusability. For example, you have a class, right? Now, what if um, what if you want to you want the child, what if you want this class methods to be used by a number of classes, right? So there is a method here, so this is the method one. Now you want this method to be available in class 1, 2, 3, 4, 5, right? Now there is something called as try principle, right? You uh, write only once and reuse it as many as times you can reuse it, right? Now it doesn't make sense to have method 1 written here, written here, written here, right? It is the same method that which we are using, right? So instead what we do is we have a parent class and then we make the child to inherit from this parent, right? So the inheriting class will inherit it from the parent. Now so but so this is nothing but called as inheritance, right? Now there are different types of inheritance. There is multi-level inheritance. So there is a, you can have multi-level, you can have multiple. So multi-level is, so multiple is basically this thing, one parent and many child, I guess. This is oh, multiple inheritances, you're inheriting from two or more classes, I feel. And it looks like, I think so, it is that way. So multiple inheritance is that way, I guess. A class can yeah, so multiple is, I guess. So this is one child, right? So instead of inheriting from one parent, you can have more than one parent. This is one and this is one. So this is nothing but uh, this is like one, and then this is two. So this is multiple, like you have more than one parent. So this is called as multiple inheritance. Basically more than one parent. Then you have something called as multi-level. Now multi-level is basically so say this is parent class A and you have B, right? So is a B is a child of A. Then you have one more class C, right? And then you have B, which is again implement or inheriting from C, right? So this is nothing but what we say as multi-level. So instead of you have A inheriting from B, and then you have B inheriting from C. So this is nothing but called as multi-level inheritance. This is we call as multi-level inheritance. So A is inherit from B and B is going to inherit from C. So this is nothing but called as multi-level inheritance. You have multiple levels. So there is something called as a diamond problem right now. So this is there is an issue, right? Resolution issue, right? If you have this type of inheritance, right? For example, if you are having an inheritance in a diamond form, so you have A in B, and then so this is a diamond inheritance, right? So this is not allowed. If you have diamond inheritance, then there will be an issue, right? So this is basically there is a chance of ambiguity right here. So this is nothing but ambiguity, right? Because now D is having inheriting from both B and C. If the same method is but in both, if you are okay, because that method we are taking from A, right? Both are taking that same method from A, and then it's getting passed down. Now, and what if I am changing that method in C? If I'm changing it over here, suppose I'm changing it in C, and I'm changing it in I'm changing it in C and B as well. Now, which change to refer? This is the big question, right? Which change should I refer to? This is like the ambiguity, right? This is ambiguous, right? Or this is ambiguity, right? Now, which change should I refer to is something but calling this ambiguity problem, right? So, yeah, it's better to avoid such ambiguity because then we don't know like which is inheriting from what, right? Like which method or which version of the method we should use. Okay, so I guess that is all. We'll see more about super method. There is some special method as well. We'll see constructors and returns, right? That is something, and then there is something called as prototypical behavior as well. We need to see prototype inheritance as well. So like in JS, there is no class I mean, now recently classes have been added, but then initially it was defined to be this dynamic behavior, right? Ready to change on the fly behavior, because objects you can directly add, you can directly remove. It is not it is very dynamic in nature, and it is less it involves less hassle, right? Creating a class, you create an object. So hence, because of the dynamic behavior, right, objects were used in OOP, in JS. So we'll see prototypal inheritance, then we'll see method, we'll see constructors, we'll see super and how super is going to affect us, and we'll see what is dependency injection, dependency remove. Then we go to solid principles, right? So I will see prototypical inheritance. There is a type of inheritance which is specific to JS. We'll see that as well. So yeah, I guess. So generics, the words are, so generics is something. There's one more term called as generics, I believe. The generics, the whole point is you uh, don't mention the type. You can change the type at runtime. It's something like that. Because if you mention it uh, at compile time, then we are directly specifying the time, right? So generics write code once used with different data types safely, right? There are type parameters. The compiler does the type checker. Now we don't hard code it, right? We can, so basically generics is like general, right? You can change the type, or you can use it with different data types. Uh, so there is something called as generics. We'll see that, and yeah. So the two thing that we need to see is basically inheritance. We'll see a little bit about dependency injection. We'll see the use of we see prototypical inheritance. We'll see how this is working there, or self is working. We'll also see uh, since functions are also first class citizens, right? So even they are stored in the heap, right? So they also have some sort of this reference. So we'll see how the reference of this works there. So yeah, I guess that is all for the session. I hope you guys liked it. I will see you guys in another one. Till that time, take care. Bye bye.